everyone. My name is Abdul, and I'm a cloud solution architect at Microsoft in our data and AI practice. And in today's video, I'm super excited to introduce to you as well as demonstrate to you our newly announced Azure OpenAI service. So as we've seen in the last few months, specifically with the rise of ChatGPT, just how transformative and impactful AI technologies can have in the betterment of our own lives. And this is why Microsoft has partnered with OpenAI to bring these capabilities to our customers in the form of the Azure OpenAI service. So within the Azure OpenAI service currently, and later with the integration of ChatGPT within the service, but this is currently not available, you'll have access to three different models, and that is being GPT-3, Codex, as well as DALL. So GPT-3 is the largest and most powerful language model that has been developed by OpenAI with billions of parameters, and it can perform many different tasks such as generate product names. It can be used for language translation or summarizations, and we'll show the different use cases of that. Then you have Codex, which is also a language model that has been trained on a large corpus of code and can be used to generate code from various texts in different programming languages. Then you have DALL-E, which is an image generation model, also developed by OpenAI, that can generate images from actual textual descriptions. So in today's video, we're going to be covering how you can actually create the Azure OpenAI service in your Azure portal. Then we're going to be hovering over to the Azure OpenAI Studio. And then we're going to be looking at the GPT-3 Playground, the different models and the deployments, what the different models mean, and what you should keep in mind before deploying any of those models. And then we're going to show you how you can actually tune the different parameters in the models that you are deploying such that it can produce a response that is more catered towards what you would expect or maybe not expect. And then finally, we're going to be looking at how you can actually use your own data by fine-tuning the model that you have deployed using Python. And that will be a quick demonstration on going into Python, generating some text, and then how you can actually feed that and work with the Azure OpenAI service using the Python SDK and the OpenAI API. So now that we are in our Azure portal, let's head on over to Azure OpenAI, or you can just search it here. I have it open here. And you can create one. I have one open, but let's just create one to see what you would need. So what you would need basically is just the regular stuff, your resource group. Right now, it's only in 3 locations, as you see: East US, South Central, and West Europe. And as this expands, it will become more available in other locations as well. And you also have just a unique name that you must give it, and as well as a pricing tier. We have one pricing tier now. You can also see the full pricing details here. And then you can just go next, tag, then review and create. So inevitably, what you would get is you would get launched this. And this is where you can actually access the OpenAI Studio, which we will in a second. Just a few things to note. Here is where you'll grab your keys and endpoint URL. And this is how we are actually going to connect to our OpenAI API through our Python SDK. So that's something to note here. You can also configure private endpoints, and you can create managed identities using RBAC as well. And you can do it all through here. So with that being said, let's go on and go to Azure OpenAI Studio, and let's see what that is all about. So when you first launch the OpenAI Studio, what you'll inevitably get is the page that I'm looking at here. And in it, you will have different use cases of how you can leverage Azure OpenAI Studios and the different contexts of which it can be applied to. So let's go through each one and see how you can leverage OpenAI, the OpenAI service for this. So one of them is you have summarizing text use cases. So how can that work in a business context? So let's assume you're a law firm, for example, and much of your job involves maybe reading like tons of precedents or legal findings or court filings and stuff like that. And with Azure OpenAI, you can use this summarized text deployment, and you can have all these summaries, which effectively reduces your workload from hours to minutes. So you don't have to go and look through all these different court filings and legal filings, but just get the main idea. And then another use case, for example, is like you might be a consulting firm that has to review a quarterly earnings report from a customer, and you can also save countless hours by asking or having an application that basically would summarize this particular task for you. Another way we can leverage it is through classifying text. So this would be, for example, particularly handy if you're an organization, maybe that's providing a product or a service, and you may have reviews that are incoming at a very, very fast rate. Say you are Amazon, for example. Then in that case, you don't want to be reading maybe thousands of reviews, but you just want to have a general idea of what is maybe the sentiment that is revolving around them. You don't want to have to swift through all these different comments. So one way to effectively manage that is through this sort of deployment. And then another one, obviously, is the natural language to SQL. This is what we have right now. And if you have maybe a business intelligence team that is building a lot of your reports that require a lot of SQL, you can basically have a prompt for them that makes their life a lot easier. You don't have to build these complex queries because by just feeding what you want to be extracted from your particular data, this would be automatically extracted or built. The SQL query would be automatically built for you. And then for generating new product names, say you are, for example, you're a business who constantly needs new creative ideas and names for your products, and this can be very helpful in that particular scenario. And now you see that there's different ways to manage and deploy all these different models. What we're really going to be focusing on is how you can actually fine tune the model itself so it can generate better results. So just the idea of fine tuning is when you have a pre-trained model, and in this case, it would be one of the OpenAI models that we have. How can you make it adapt to a specific task or maybe in your specific domain if you have a particular niche industry that doesn't have a lot of data, for example, that the model learns on, and you want to have as much data as it can to make the best suggestions or generate the best responses or whatever the scenario is, then this is something very important because what you're able to do in this case is provide that data set on top of the pre-trained model. And this would not only increase and make the queries more efficient, or not queries, but make the model run more efficiently, but is able to generate a finer and higher detailed answers for the questions that you're providing it, because then it would be more domain specific from that regard. So just something to think about. This is what we're actually going to be doing in Python, and I'll explain to you how we can do that. So if we click on the GPT-3 Playground, you're presented with this environment. And this is an environment where you can test your different deployments, which contain the different models that you are deploying and the different examples. So over here, you'll have different examples such as summarized text. You'll have a generated prompt, and it will give you how you should structure your prompt to generate the answer. So for summarized text, you have to add TLDR. If we write generate here, it'll take a second and it will generate you a response. Now we'll see in just a little bit how playing with these different parameters and what they mean and how that can shape the result of the response that the model is outputting. So now we go to deployments, and if you create a new deployment here, you can select the model that you want to deploy. And that is from the list of all these different models. And you have the ones that are already deployed. You see Text Davinci 002. If you've already deployed it, you can deploy it again. And you just select the deploy name and you hit create. So now if we were to go to the actual models, and let me just explain a little bit of what these different models are. So they are separated into two different categories. So let's talk about the GPT-3 perspective. From a GPT-3 perspective, you'll see that the one we deployed is Text Davinci 002. So what does this mean? So the text is basically the task or the family of the type of the model that it belongs to. So this would be text. Then the name of the model is Davinci and the version number is 002. So this is the second version of the Davinci model. So that's something to consider. As you can see here, Text Davinci 003 has just recently, it was the latest Davinci model that was added to the Azure OpenAI service. So then we have, so let's talk a little bit about DaVinci actually. So DaVinci is the most powerful and versatile model that's actually offered by the OpenAI service. And you can use it for a lot of different tasks, natural language tasks. So this can be things like summarization. And it has a very good capability of understanding intentions of text and really good text generation. So the only trade-off here is that from a GPT-3 perspective, this is the most computationally expensive. So this would, it would give you the best results, but at the same time, the trade-off would be from a cost and latency perspective, because this would take a little bit longer to process through this model here. And then you have Curie, and it's less strong than DaVinci, but it's also capable of things like sentiment classification and summarization. And this can be a good choice if you're actually going on ahead and building something like a service chatbot, for example. And then you have Babbage, and then a Babbage can just do simple tasks, like for example, semantic search, and it does really well on, if you have search queries, ranking how well those documents match up with those particular search queries. And then you have Ada, and this is actually the fastest model, and it can perform tasks like parsing text or address correction, so things that are not so complicated and don't require a lot of nuance. And the more text, the more context you add, the better the performance will be from the Ada perspective here. So those were the GPT-3 models. So from a Codex perspective, you'll see that we have Cushman. So Cushman is actually utilizing Codex and is able to run a lot cheaper and faster than DaVinci if you were to use DaVinci for this particular purpose. And DaVinci is also capable of the Codex functionality, so that's something to also know. We recommend when you're actually choosing between the models is to start off with the DaVinci model when experimenting. And once you have like a solidified prototype done, you can then optimize your choice for the best latency and the performance, and seeing if the trade-off between those two are things that are acceptable for your application or for your particular use case. And when we're going to dive into how you can create a customized model by fine-tuning the existing model, that's also another consideration to have. Fine-tuning a model like DaVinci is going to have a much major impact or a much major disturbance on your cost than a model like Cushman would have. So that is also something to know. So now you just have a quick idea of all the different models and what they're used for, and all the different ways that you should keep in mind, and some general best practices to keep in mind when you're deploying a model. So now I do want to go back to the GPT-3 Playground here. And as you saw earlier, we were able to summarize this text. And one thing that I do want to highlight is if you go on the right here, which says view code, it'll give you the actual snippet that of the Python snippet that you can then move over to, for example, your Python that's running on your VS Code, and try to test out this exact model by changing the parameters there. And just one thing to note is, it gives you everything else. It gives you the API version. If you have environmental variable with your Open API key that we showed earlier when you were deploying the OpenAI resource, or where you can find that. So I just wanted to keep that there for a second, and just show that you can actually give you the Python code that is actually you can transfer over to your VS Code. So before actually heading on over to Python and working with the Azure OpenAI API through the Python SDK, let's just go on back and familiarize ourselves with the different parameters and how changing these parameters would inevitably have a different result towards maybe the response, as well as what you would expect or what you would anticipate the response to be. So let's head on over to the parameters, and as you can see, for each single one, there's an explanation of what it is. I'm just going to give a commentary on top of what these mean, just because it might not be fully clear. So with temperature, think of it as, it says here random, but think of it as like maybe a creativity bar, and it controls basically how random or how diverse you can think of the responses you're going to be generating are. So if this is set to 1, then what would happen is it would be very random, and it would be very creative. Like, just think of it, the temperature is a creativity mark. So maybe you want to have more conservative anticipated answers, and you would just set this temperature to 0. The max length is just the token. So a token is a way for the model to break down this text into smaller fragments so it can be able to process the model and do everything on the back end. And the tokens you're seeing here 72. So how would classify a token? It would be maybe classify the following news article. Those are all different. And even punctuation marks are actually considered as tokens as well. So if we were to set this to 60, that means the response is limited to this number of tokens. So this would be a very small response, and we can crank it up all the way to 2048, and this would be maybe a longer response because it would use a lot more tokens. Then you have the top probability. So how the actual model knows which word to choose subsequently, one after the other, is through probability distribution. And this distribution will basically calculate the probability of a certain word to be placed in a given scenario, given its distribution. So what this means in essence is, let's say this is set to 0.5, right? Let's just say this is set to 0.5. What it means is when the model is being run, the model will only consider the top 50% of the most probable words when selecting the next word. So this will lead to a little bit more predictable responses. But if it's put to 1, that means the response would generate, basically doesn't have a regard on the distribution or the probability of the word following another word. So this would lead to more random responses. So the frequency penalty is just how it's described is just how repetitive the generated text is. So the less if this is 0, it means it would make the generated text a little bit more repetitive. If it's set to 1, it would mean that it would not repeat words or phrases. But sometimes the trade-off here is that maybe it would lose some of the grammar ability, or maybe it won't be as coherent. And then you have the presence penalty, and the presence penalty just controls how much of the input text tokens are being utilized in the actual output. So you're seeing here words like new, kind, perfection, beloved. So if this value is set to 1, that means the model would be, or whatever it's 2, it would mean that it will be heavily penalized if it uses words coming from this input text. So, but I guess the trade-off here to this is sometimes, because it is really focusing on this penalty because it's so high, well, what would happen is it would maybe lose its coherence, the context, and the grammar would also be problematic from that respect as well. And setting this too low, it means, you might have words that are very, very repetitive that are coming from the input text itself. So this is also something to keep in mind. And the best of is just basically determining how many results from the actual response is going to be evaluated such that it will choose the best one to display back to the user. So if there's only one, whatever the first result of the model is, it would be what is going to be displayed or what is going to be responded to from the input prompt. And how the selection strategy could be is using these things called pre-response text and post-response text. So in a post-response text case, it's the parameter that adds text at the end of the response. So this could be, for example, the end. So the best of would prioritize responses that have the responses ending with this particular text. So in a very high level, this is what all these different parameters are, and we're gonna show you right now in a second how utilizing or changing these parameters in a very quick way will yield different responses. So let's make an example and write, please write a short story on Abdul, who is working to provide a tutorial on Azure OpenAI, right? And for the case of this, I just write this to 0.3. Maybe this is 500. Maybe the stop sequence would be the period here. The top probability would be 1. And the frequency ability will be 1. Presence penalty, just put it as 1 as well. And best of 1, and no pre-response text or post-response text. So what we'd anticipate here is maybe we'd see just a longer response with a little bit more detail and less randomness because the temperature is set as 0.3. And the top probability is 1, and we have a decently frequency penalty. And so this will be, let's just see what the result of this would be. Literally providing tutorial on Azure OpenAI is having a lot of fun, was very excited about the new project. However, he ran into some trouble when he tried to access the Azure portal. He was unable to log in and eventually gave up the end. And the reason why you saw the end is because the post-response text was the end. So it prioritized any response that had this sort of, or no, not really, because it only had the best of 1. But if we were to put like 5 or 10, it would prioritize responses with this being the very end of the response, right? So then the next example is, let's just make it more random. So this will be, like I said, this is our creativity sort of marker. And let's just shorten this a little bit. So this is 256, right? And we'll have, instead of the period, actually we'll just keep it as the period. And the top probability, let's keep it at 1. The frequency penalty will be 0. And let's just put the presence penalty at 0.5. And we'll keep it as 0.1 here, and we'll just leave everything as is. So what we would expect here is it would obviously be a lot more imaginative and creative, because it has a high degree of randomness. The presence penalty was set at 0.5, and this will maybe encourage the model to generate content that's a little bit different from the actual prompt itself. So let's see what this will generate for us. Okay, so Abdul was very disappointed that he was not able to log in. He had been looking forward to writing the tutorial and was very excited about the project. However, he was unable to log in and eventually gave up. So you can see maybe the prompt itself is not very, it doesn't give very ease to being a little bit more imaginative, but that's inevitably what it is. But now let's just maybe tone it down a little bit, and maybe we typically suggest the temperature to be 0.5. Let's increase the tokens to maybe 1,000. Top probability 0.5, and then 0.5. Presence, maybe we'll make it as 0, and I'll just change this over here. So what we would see is here is like the story is a little bit more focused and less random. So the lower top of the probability, what we had here, the lower top will cause a little bit of a decrease in the randomness and in the words that are going to be chosen. So just see. One second, generate that. Abdul was working to provide a tutorial on Azure OpenAI. I have a lot of fun. He was really enjoying himself. He suddenly realized I didn't do something. He tried asking for help, no one could help him. He was getting frustrated and was able to give up. When he figured it out, he was happy, and so on and so forth. So this is how you would be able to sort of just maybe change the parameters, play around with it a little bit. You have a good understanding now of what each of these mean. And I just wanted to do that because this may be important in you trying to understand, hey, do I need to fine tune the model to be able to learn more things, maybe things that are very business related. Maybe it's subject matter expertise that you only know based off of your experience in your business. So in this case, what we can do, and this is what we're actually going to be doing next in Python, is how can we fine tune this DaVinci model in a way such that it would, we give the data of our training data and our validation data, and then it will be able to build on top of the pre-trained existing DaVinci model so it can encompass all of your knowledge and all of your expertise in the responses. So in this part of the demonstration, I really just want to focus on what kind of data sets and how you can be able to work with those data sets in our Azure OpenAI service such that it can be fine-tuned by our model. And some of the considerations that you should be thinking about is how large is this model that we are going to be fine-tuning. See, a model like DaVinci, which is very large in nature, is going to require an extreme amount of computational resources to fine tune. So this will inevitably impact or be a consideration when you're thinking about the costing of this fine tuning job. So that's something that you should probably keep top of mind. Another thing that I just want to highlight is this idea or this terminology behind prompts and completions. So what we were doing earlier, prompts are the user-generated text that or questions or things that we want the model to respond to, and the completion is the ideal generated text from the actual AI. So this is what we're going to be using from the prompt, and when we say prompt, that's where we're going to, and completion, this is what we're referring to mainly. So in this example, we'll search through Wikipedia randomly through the usage of something called the MediaWiki API. And this would generate us new topics or titles as prompts, and we'll have the completions as the first sentence of the actual Wikipedia page article on the randomly generated Wikipedia page. So just to go back to the, just to take you to the MediaWiki API, we're going to be making a GET request here with the actions of retrieving a random page, a random article, and then through the use of beautiful soap as well as requests, we're going to extract the first sentence of the page. So let's start by importing all the libraries we're going to need. So we can import JSON, our shuttle. JSON is going to be working with GET requests we're going to be making. The shuttle will be used to be working with the training and validation data sets that we're going to have from OpenAI and for CLI. This is what's going to be used to actually interact with Azure to create our fine-tuning job. Then we have our MBS4, import beautiful soap. This is an HTML extractor. And we have requests. So what we can do then is we can create a sample data, which is just an empty list, and it just generate just 100 different prompts and completions from Wikipedia. And remember that we used the page that I showed you to gather this. So this is the API, and these are all the different actions parameters that we can do to retrieve. We can create this into, we can turn this into a JSON. Then we can write query, random, 0, and we need to get the title. So if we run this real quick, you'll see that it generates a random title. If we run it again, it will generate another random title. So we need to actually attribute this particular title to a text, some sentence. So we can, that can be our completion. For that purpose, what we can do is we can write def get summary. And why are we doing all this is because when we are trying to train the model, we need to give it some prompts, and we also need to give it some completion. So the first sentence, it just sounds like an easy way for us to accomplish this, just for demonstration purposes. So we can write response, and this would be request get. Grab this so we don't have to write it again. And we're going to be passing the title, and we're going to actually name this the title as well. So this is going to be past the title, and then what we're going to want to see is if it's empty or not. So we can write beautiful so response text, and then we write HTML parser. And what we need to find is in this we can write find div. If it contains a no article text, then in this actual class, so if this is true, then return none. If it else, then you can return so select one, and this would be div parser p. And we need to remove the first sentence, so we're going to text split this 0. We're going to take the first sentence and we're going to split it based on the condition that it sees the first period. So with this being said, what we can do then is we can have a while statement. And this while statement checks the condition that the get summary is true. It means there is, that it's not empty. So what we can write there is summary, I get summary of the title. So let's just to go back about and just explain what we did real quick. We created a response. We gathered the title, the Wikipedia title from what we just received here that randomly generated. We parsed the HTML content, found this particular class and saw if it exists. If it does exist, we need to exit out of this and do it again. This is why we're checking if this is while true. If this is true, that means when this returns as true, it goes back and does it again. If not, it will return this, right? So I just wanted to make sure we just covered that briefly. So then if this is true, like we just said, we need to break out of this for loop and we need to append the sample data, right? So prompt, title, completion. And for the completion, the way that the data has to be made and passed into Azure OpenAI to actually be fine-tuned, it needs to have a space or a character, and the first character has to be a space, and we can write just add summary. And everything should be good now, and if we just run this, we'll see, we'll just wait until all of the results have came back, and I'll be back when this is done. So sample data has finished generating, but I'll run it again. And just to showcase that there is, there's different prompts as well as their completion, and the completion is just basically the first sentence of the actual title of the page. How can we use the CLI to actually start the fine-tuning job and create our training and validation data set? And this is where I actually do want to take you over to the documentation because all of this work has been done mainly for you. And so if you can just copy and paste this kind of information here, it'll be here, and then if we go back, and I'll explain what this is doing in just a second. So we're creating the training and the validation file names, and the training name is with lines, and as well as it has to be in the format of JSON lines. It is generating the training data set from the sample data set that we have from the sample data. And as well as it is copying the validation set from the training set. And now it's creating from the CLI the fine-tuning job to our Azure OpenAI service using our credentials here. So just make sure we ran that. And we can, let's see what happens when we do this. So you're seeing that the training ID and the training data is actually being uploaded right now. And now the validation data is being uploaded. So where are we going to find this? So if we were to go back to our Azure OpenAI Studio here, and then if we were to go to models, or sorry, file management, you'll see that there's two files that have just been uploaded. And these are the files that we are just uploaded from our Python script. So now what we can do in a very, very easy way, you can either do this in Python by following along and through this documentation, or we can go through models here, create a customized model. The base model you would select is Davinci, and then you would use the training and validation data from the actual file management that we have here. And this would create your own customized pre-built model. One thing I do want to highlight though is what I mentioned earlier, which is because we're using such a expensive or computationally expensive model, it means it's going to take a lot of computational resources to fine tune the model. I also do want to highlight that in the file management, there is also another way of actually putting or managing your training and validation data set or ingesting it here, and that is through the upload a new data set. You can actually link this to your ADLS2 storage, for example, or if you have something locally, you can do that as well. And And this is just another thing that you can do aside from the example that we just showed in Python. I just wanted to show how you can interact with Azure OpenAI service, how you can maybe clean the data or make it in a way where this would work from a fine-tuning perspective. And then once the deployment or once the customized model has been completed, you can go back to the playground and then choose that model that you have created, and then begin to see if it has if the pre-training, or sorry, not the pre-training, but if the fine-tuning has worked to your liking. If not, maybe more data needs to be ingested into the model for fine-tuning purposes. So to summarize what we went through in this video, we discussed about the Azure OpenAI service. We showed how it can be created in the Azure portal. We moved over and talked about the GPT-3 Playground alongside the deployments as well as the available models there are. We went to Python, generated some sample data, and showcased what kind of formatting that the fine-tuning job would require, and previewed how you would actually fine-tune the job using your own data. And I hope this was informative and educational for you. If you found this helpful, please leave a like and a comment. And don't forget to subscribe. I'll see you in the next one.